Awesome. Thank you so much. Yeah, we'll wrap up only after I tell everything about the component store. Actually, I won't have time today to tell everything about the component store. I'll touch on a lot of things, and hopefully, there'll be more questions and further presentations on it as well. A bit about myself. I'm Alex Okrushko. You can find me on Twitter at Alex Okrushko, and my DMs are open. So if you have any questions about today's presentation or anything like that, feel free to shoot me a question, and I'll try to answer it. I'm working on Firebase Console currently at Google, as I was already presented also in the ngrx team, and I'm very happy and proud to have the Angular Toronto community of Angular developers here in Canada. So I'm organizing that meetup. And I'm also very proud to be part of the fantastic people at the indepth.dev, which is a fantastic community. If you're not subscribed there, make sure you subscribe. It's really awesome. All right, so that's a little bit about myself. So what are we learning today? What is this ngrx component store? Well, it's a state management library, right? And you might think, hold on. Doesn't ngrx already have a state management library? Well, yeah, there is ngrx store, right? And this is a global state management library. So this component store is a completely separate library that doesn't depend on it. It's self-contained. It's basically like one file with an extra operator. So it's very tiny. It's very performant as well. So this is the one that I'm going to be talking about today. But state management. Okay, so what is the state management thing we're talking about? Well, we have a state, and we need to manage it. And before we dive into those things, we want to understand what is the state? What is this state thingy? And again, there are multiple ways to slice this and present this, but my mental model about this is the following. We have a server and we have a web app, right? Server keeps a server state, no surprise there, it's a backend state. And this is basically a source of truth, right? So this is all the state we save, it's there. Then on the web app, we have a bunch of different states. There's more, but we'll talk about these four today because they are interesting in the component store realm. And we'll start with the persistent state. What is the persistent state? And I'll show some examples based on the Firebase console, so I'm working on it, and why not, right? All right, so the persistent state is the state that we get from this. It's from the backend. It's a piece of state. It's a snapshot of some of the state that backend had at some point when we requested this. So this is a persistent state that we get within the application. We also have, URL state, or the router state, sometimes people call it. And this is, to no surprise, is the state of the URL. Sometimes it's router state, so it has a little bit more things like data and stuff like that. But for what we care about is the URL itself. Then there is a client state. This is, for example, something that we don't even persist to the backend. For example, which tab is open right now? Here is a sign-in method tab is open. This is the type of state that stays within the app itself. It's not going anywhere, but the app itself is aware of it. So it could be shared around, and it's aware of the state. And then the last one is the local UI state. This is the state of this enable button, right? So enable button by itself knows that it has two states, basically on and off. It doesn't care what it is. It's very it's called dumb component. So it's very included within that component. It's not shared everywhere. It's passed, should it be enabled or disabled, maybe by an input, and when you click it, it communicates to the output. So it's basically like a very common component or a very localized UI state. All right, so those are the four states we have, and the typical problems that we have within our applications is how we can synchronize all of those. So this is where a lot of the challenges happen. How do we call APIs? How we persist the state? How we read it? How we update it? And all of these between. We change the URL, the client state needs to change, a specific tab needs to be shown. Some APIs need to be called. So all of these synchronization is what the state management is all about. So how is a component store managing this state? Well, component store, just like any other thing or any state, it needs to do three things. Basically, first is we need to be able to read the state, right, locally, and then we need to write the state, and then we also have some side effects, which we'll cover in a second, and we need to organize and manage them as well. And if you're familiar with the global ngrx store, you probably have seen the create selector, create reducer, or create effect. Those are like the factory functions to either read, write, or create some side effect and manage that. Well, as you might be, there's no surprises, I guess. Component store also has a way to read it, and we call this a select method. There's a way to write the state, and we called it an updater, like updates the state. And effect, well, the side effect is just an effect. There are a few more methods, but we won't be covering them today. And even, and even some of those methods we see only to be used in a specific places. For example, like get, we only want it to be used in effect, so it's even protected and not publicly available. Anyhow, so those are the APIs that we have for the component store. Component store in itself is supposed to be a better version of a service with a behavior subject, right? So this is a push-based service that has the state and reacts to things. And it's a better version, I say, because we also have like a side effects to manage all of those race conditions, which we'll get into in a second. So how do we write the component store? The typical way I see component store written is first we need to tell it which kind of state it operates on. For example, we have statuses of different statuses: unsaved, error, loading, and loaded. For example, we have an author state, right? We have his ID, name, some books that are associated with this author, books IDs, and in the status of this API to load the author state. All right, so this is the interface this is the state that we'll be working with. And again, component store, unlike global store, it's supposed to be very localized. So the scope of it is very different. So the typical way we would write it is we'll create this author store and we'll extend the component store. So component store comes with all the tools we need. It comes with a way to read the state, it comes with a way to write it, it comes to how to create side effects. But we need to add some meat to it, add the logic how to do this. So what exactly are we doing? So that's why we create this author store, which just extends component store, which is a toolbox. All right, the first thing we can do is here initializing the state. You can do it, or you can do it later on, up to you. There are ways to do it, which we won't cover today. But here I'm initializing the state. I want it to be, for example, unsaved and having some default values. All right, so now we are to read. How we read it? Well, we read it with a select, and it's very simple. So again, select has a callback method, but basically is a prescription. We have a state. How do we extract something from it that we care about? So again, all of these read, writes, and effects will all be answering the how question. So how we select. So we have the state that has IDs, names, statuses, and stuff like that. We want to get a name out of it. So this is how we do state, and state.name, we get it back. And this returns us, as you can see by the $sign there, it's an observable of strings now. All right, so and we make it a read-only, so just nobody changes it by accident. So again, this becomes a push-based service, right? So our author store is a push-based service. So how would we use this? How would we use this name? So we have our component, like author component, that has a few things. And let's see how we would use this author store, right? The store that has the business logic that's associated with changing the author. So first, an important thing is we would put author store in the providers. Why would we put there? Well, when we put it there, that means that this author store would be tied to the life cycle of this component. So for example, when the component would be destroyed, this store would be destroyed. Another thing is if there will be multiple of author components, each one would have their own unique version of the author store, because it's really we're tying the store to a particular component. That's why we would provide it in here. Okay, So then in the injector itself, we would do the private read-only author store, and we inject this author store. So now it becomes available to our component. All right, so now with this name, well, it's very easy, right? Because it's a property on the store. And now we can extract it and use it in a template or anything else. And it's very push-based. So whenever anything changes the state, it gets pushed to this name, and our component can react to this. All right, so this is how we select it. How can we update it? How can we update the store? All right, so let's look at that. So we would write it with the updater function and a method. And this method, again, tells us how we change the state. So for example, given the state, the previous state that we have, which is the first argument, author state, and given the new status, some kind of new status that we get into this update status, we would show how we would immutably change the state to this new one. So for example, we would spread the previous state. So any properties that we had, like ID, a name, they all stay the same. And last one is status. We would override that status. And this property, it's not actually a property. It is a property, but it's a callable property. So you can think of it as a function. And if you can see below there, this update status would pass a value to it, loading, right? Would pass a status to it. And what it would do, it would change internally the state to loading. And if we are reading it and selecting it with the selector somewhere, it would right away react and pick up this new version. And down below, for example, we have update status to load it. So see, those are how like imperative functions that you can call and basically update the status very easily. And the whole thing reacts to this. Awesome. So this is how we write them. How would we, so the next one is an effect. Effect is a little bit more involved, so we'll get to this. But I feel it's such an important part of a component store. And actually in the ngrx, the global store, there's ngrx effects, which again, I think is one of the most crucial parts there is, because it allows us to handle those race conditions that we never test for. It's hard to identify, and we sometimes don't even think about it, right? If we have just a method on the service that does and calls like HTTP call and gives like a 0 back, you know, if the user clicks and invokes that method on the service multiple times, now we have a race condition. And if we're updating values, now we're in big trouble. All right, so that's what effects are for. Effects are for handling asynchronous things, but also at the same time controlling all those race conditions. All right, so let's look at this one. So we have a get author effect. And what it takes an observable of IDs, right? So what are those IDs? Those are author IDs that we would be pushing into this one. We'll see how exactly, but think of it as our callback gives us this ID and asks us, how would we handle, you know, that stream of IDs that we have? All right, so the first thing that we would do, we would filter. We ignore that for now, and then the next thing we would update the status. Now we consider it loading, right? So now if we select the data from about the status, we would know that it's loading. So this is what a tab operated basically is, another side effect. The next one is super critical. So this is where we handle our race conditions, and here we use a switch map. If you know, there's a switch map, merge map, exhaust map, and concat map. All have different ways to do it. So they all handle different, the incoming stream of values and how you would handle them. Would the queue, would a switch map would drop any observables it's working on, or concat map, you know, will queue them, and exhaust map will drop the incoming ones. So they're basically, those are strategies how we handle those race conditions. So here we would do is we would call our author service, and we would get that author by a specific ID. Once we have this result, we will call the tab next, and we first of all set the author. Set the author is an updater that sets the author into our state, and then we have another update status, which is another updater, and now it sets it to loading. If we have an error, our update status was set to error. right? And somebody else, somewhere can pick it up and show the error message. And one last thing is, if there is an error, right, we basically need to catch this error and transform it to empty before we flatten this into the main stream. All right, so those are the side effects. So we can select, we can update, and we can cause those side effects. Side effects is basically the orchestration of all the asynchronous stuff we do, calling the services, handling race conditions, and stuff like that. All right, so how will we call this effect? Well, we can call this effect, for example, in the input of author component. For example, this author component that takes an ID of an author ID and says, hey, this is what you get. Do whatever you want with it. And what we do instead is like, okay, author store, give me this author, and it pushes this ID into this. Notice it's not an observable that I'm pushing it. I'm actually pushing a single value into it. But every time I call this get author, right? For example, if a parent component changes mine, it pushed me another ID right after, a few seconds, while I was still, retrieving the first author, it would be pushed into this observable stream that we saw above, and it would say, oh, you know what? We have a new ID. We don't care about the current one. Drop it and start another request for the get author. If it was just, a service with a method, it's very easy to overlook those. And we could have gotten the condition, in the race condition, where the first request actually gave us a result second, and we could have had a wrong author. Those are like those tricky race conditions that are really hard to get right. And the component store is one of its purposes is exactly that, giving you the tools to work with in a very nice way. All right, so this was the effect. So how is it different from the global store? Well, there are a lot of differences. We'll cover some of them. So for example, in the ngrx store, it's really meant for the global state of the application. And as such, it scales a little bit differently. We split things by separate files because it's supposed to be a lot of things, right? It's a lot of global things, and we split them by almost like responsibilities there. So selectors are separately, reducers are separately, effects are separately, and they're all in separate files. ngrx component store is supposed to work with the smaller data sets, smaller effects, smaller state, and the state for that particular component only, or its children. So it's all in one single file. So this is like one of the, the first difference. So selector data and effect are in the same file, and they should be in the same file. There are some additional selectors in a separate file sometimes, but we won't cover that today. All right, so what are the differences? Well, ngrx store, even though things are all separate, it's a one single state for the entire application, right? So it's one single, even if we do 4 features, they are patching the one single object of immutable state. Each reducer there is responsible for its own slice. That's true, but it's still a one single state. While in ngrx component store, it's not the case. We have multiple independent states. And this is why it's super, super crucial to not duplicate the state, to really understand who's the owner of what kind of state, where should you push component store in the component tree, should you have it. This is super important. So again, there are multiple independent states. They're not talking to each other, and they shouldn't be even talking to each other. There should be a clear ownership of the states. Okay, so those are those two. And lastly, ngrx global store it lives for the lifetime of the application, right? So we keep the state is there all the time. While the ngrx component store, the way it was designed is it should clean up after itself when the component containing it gets destroyed. So this is, again, quite important ways to distinguish those. So where should we use component store? Well, I'll cover a few cases today, but there are a lot of use cases as we discover, as we start using it. Within Firebase, we've been using component store, its initial version, for, what was that, almost a year now. No, actually, yeah, since like November of last year. So there are a lot of use cases. We'll cover some of them. First, we'll cover like a module state. Then we'll go into the shared common component state, and this is actually the state that that basically gave birth to this component store within Firebase initially. Then there's a complex independent component state, which is kind of very related to the module state. Reactive local UI state as well. And the last one is provided in root. I put the warning side there. So again, component store is designed to be used with the component lifecycle. You can, in theory, provide it in root, and there are some cases for it, but basically be very careful with that. All right, so let's start with the module state. What is this module state? It's not an ng module state. It's not JavaScript module state. It's a whole different other module state. And what we call the modules is something that's completely independent within the application and self-contained as well. So, for example, we have multiple in Firebase console. We have multiple pages, right? We have page for authentication. We have page for database. We have page for storage, and each of those pages open, and they're almost like completely independent state-wise from the rest of our application. Yes, some of the state does trickle down from the global component, global ngrx store, for example, like a project number that you're working with, and in a few cases they are connecting to some other modules, but mostly it's a self-contained piece of a component tree. All right, so that's the module state. Let's look a little bit into this authentication one. This is the one that I was working on as well, so it's kind of very familiar for me, and I'll try to explain what exactly I mean here and how we would use the component store in this example. So when you click on one of these providers, like this one, email password, it opens up. So this is a provider page. You can do the same thing and click on phone provider, and it would open up the same provider window. So basically, those are providers. We can for authentication, and we also can have like a third-party providers, like Google is a third-party auth provider, or even Twitter. Like those are all providers, and we can think of them as a provider component, right? They're kind of independent. All right, so we have this providers component, but then they're not just by themselves. They have to have a parent component, and in this case, this is their parent component. It'll be like an identity provider, so it contains a bunch of providers inside it. But even that, if we scroll a little bit down, there's more happening, and even this page by itself, it's a tab. It's a providers tab. It has quota at the bottom. So basically, this is our component tree. Again, very simplified, right? How they contain each other. All right, but then we have also other tabs as well, right? So our authentication page is actually bigger. There's users, there's templates. It's quite bigger. Like we have all of that. And let's just for the picture here, we'll put it as well. So there's a users tab with users tables, some row templates tab, and we have like authentication index page. So this is the one that contains the whole module. And the way the APIs are structured for authentication, for example, is that we have API get some config, and config covers all of these users. It covers providers, it covers some of the template stuff. So it's API that just goes and gets a lot of things at the same time. Because of that, we have to have a way to store that data. And what we decided to do is to have the auth config store, and it's basically the one that is tied to the lifecycle of the auth page, and then it shares, once we get the API results, it shares all the data throughout the different components, and they can basically talk to the store to get the user data, to get some of the quota data, to get some of the providers or templates or other stuff. Sorry, Mark, I'm busy right now. Yeah, so anyhow, that's why we have it all this way, and this way it actually owns the state on that page, right? So this is where it covers it. So auth index page owns all of the config, and it's not shared anywhere above it. So it's only shared Here. Sorry, can you close it up, please? Sorry, I have Saturday. All right. Okay, so getting back to this one. All right, so we have a config store that shares all of this data throughout. Moreover, we have another store, which we have an onboarding store that's also is on the page. So what I wanted to show here is that there could be multiple stores at the same page level. It could be stores below this. It could be stores above it. But it has to. You have to have a clear understanding of at which level we actually, the state is owned, right? So it's owned at that particular level. All right, so that was the module state, and then the shared common component state. And this is actually the one that, kind of gave birth to this component stuff. We had a problem where we had quite a complex component. So for example, we have an app, right? We have multiple pages, right? With different pages, different things happening. And then, some pages have different components and stuff like that. So just have that. But then we have a common component. It's a shared component. It's a component that's like dumb. It talks to the outside with its parents through the inputs and outputs. All right, so we have those common components, the different pages, but that component is quite complex, and you could have its children too, and its state could be very complex, and then you might need to call the services directly as well, maybe for validation or other things. But we wanted to have that state. And basically have that state self-contained somehow. And we didn't want to push it to the ngrx store because it didn't have even any, place. It shouldn't be in the global things. It's not really shared anywhere, right? So common component is actually the one that owns it. So what we ended up doing is having those component store, right? And as you show as well, when you provide that component store, in this case, it would be individual and unique for each of those components. So this one was a very interesting case, and this is the one that basically gave birth to this component store. All right, so this is third one is a complex independent component state. So it's kind of like a module one. So we have multiple pages. We have a component A, which again owns the state. It's not shared anywhere. But components B and C want to have some of it, maybe transformed in a transformed way. D might want as well, and all that stuff. So we would, and then we also wanted to have everything cleaned up when we move to page 1, for example. So again, we would create a component store that's tied to the life cycle of a component A. In this case, it's the one that owns the state, and then it's basically shared through those selectors down. And if those components need some data to be changed, they call either those updaters or they call those effects and push some new data into it. So this is it's kind of like a case of a module state as well, if you can think of component A as a module. All right. The other one is the reactive local UI state, and this is what Michael's been touched on as well. For example, if should you go zoneless, you have a local UI state that's reactive, and if it's just the property that you change, you need to know to change deck or whatever that you need to update that and all that stuff. So you can use those push pipes and the rest of the things. So you need to have your local state reactive as well. So component store can also be used for that. And then the last one was the provided root. Again, you have to have a clear separation. If there's a little bit of a state that's not shared anywhere much, right? And it could be used, but it's self-contained state, doesn't have a lot of inputs from other places, then it's kind of okay. But the first instinct should be probably, if you have something really global, the first instinct should be in the ngrx store itself. By the way, a component store does not depend on the ngrx store, the global one. It's completely self-contained. It's supposed to be a replacement for this service, with some cache or some state, a push-based service. I've written the design doc for it. You can search for it, Componentstore design doc. You'll get on this. And one of the last things I want to say, huge thank you for these people. Kevin Elko, he's my teammate at Firebase. He's the one who started the component store internally, and then talking with the ngrx team, we decided to push it upstream basically and share it with everybody. I've had these questions. Hey, how I have this multiple instances of the same component that's fairly large and have self-contained state. How can I do this with the ngrx? And the answer was like, well, you can kind of put by index by ID in the global store, but they're like, well, they don't do it and all that becomes clumsy. So yes, this is why it was created. I also would like to thank ngrx team, Brendan and Tim. They've been reviewing this and providing feedback a lot. So thanks a lot for them. And also Nicholas Jameson, who was also crucial. Even the one of the custom operators that we have as part of the component store, which I didn't cover today, it was actually written by Nicholas. He's a fantastic guy. If you don't follow him, you should. If you didn't read his blog, you missed like a ton. It's one of the best blogs there is. So I'd like to really thank those people. They're fantastic. And lastly, so component store, I'm working on a guide right now. There's not a lot there right now, but hopefully soon. And component store should be released with the upcoming ngrx v10 release, which again will be happening fairly soon. So the docs will be updated by that time, and you can right now already go and play with the nightlies builds, and if you want any feedback, if you want to have any feedback for the component store, I'll be very happy to listen. But looks like we're like where it's getting, and so far I had a lot of fantastic feedback. So that will be it from me. Thank you so much. If you have any questions, again, reach to me. Twitter is the best way, and I'll be happy to answer them. Now already go and play with the nightlies builds, and if you want any feedback, if you want to have any feedback for the component store, I'll be very happy to listen. But looks like we're like where it's getting, and so far I had a lot of fantastic feedback. So that will be it from me. Thank you so much. If you have any questions, again, reach to me. Twitter is the best way, and I'll be happy to answer them.